What up? It's your boy C. Rizzy coming back at you with Unit 9, Lesson 4, Composition of Transformations. Our essential question is, does order matter when drawing a composition of transformations? And our objective is to draw multiple transformations given an original pre-image. All right, let's just go over some notation review. So what does a translation look like? A translation is a capital T, and then usually it gives you some x comma y and tells you what to do with it. And a reflection is a capital R, and this is the line of reflection usually given here. And a rotation is a lowercase r, usually around the origin and given a certain amount of degrees to be rotated. Now, a combination of two transformations is what we're doing today. It's called a composition of transformations. So now, instead of doing just one transformation, whether it be a translation, a rotation, or a reflection, we're going to do two of these, one first, then we're going to do it a second time. So here's the notation for a composition of transformation, and it's read from right to left. So when you see this notation, it's read a reflection in the y-axis followed by a reflection in the x-axis. So the first transformation is and this should be a capital R, reflection over the y-axis. And the second transformation is the reflection over the x-axis. So that's exactly what we're going to do. So given triangle ABC, which I've already given to you and drawn at the right, find the composition of transformation of a reflection over the x-axis and y-axis and label the image appropriately. Do not forget to state all the coordinates. So the first transformation we're doing, again, because it's read right to left, the first one is the reflection over the y-axis. This is a reflection of the y-axis. Okay. And if we follow our transformation rule, reflection over the y-axis, the original points become negative x, y, meaning that the x values will change sign and the y values will stay the same. So our new triangle will be at A prime will be at negative 1, 2. B prime will be at negative 5, 5. C prime will be at negative 5, 2. Or the other option is to do our counting method, right? A goes 1 to the y-axis, 1 more. You get A prime. C, we would count 1, 2, 3, 4, 5. Stop. 1, 2, 3, 4, 5. There's C prime. And then B prime, we'd count 5, 5 more. There's B prime. And I'll connect our dots. I'll make sure this is the appropriate color to get our new triangle. Okay, so there's our reflection of the y-axis. Now, the second composition is the reflection over the x-axis. Now, we don't go back to the original image. We don't go from black to green now. We're going to go from red. We're going to take these points, and now these we're going to reflect over the x-axis. So now the rule for reflecting over the x-axis is you keep the x value the same, but you change the sign on the y value. And again, we're not using the original set of points. We're now using our new points. So we're going from A prime to A double prime. So now this is going to be at negative 1, negative 2, negative 5, negative 5, and negative 5, negative 2. Okay, and we'll graph our reflection over the x-axis. So again, we could count or we could just plot our new points. A double prime, and I'm using green now. A double prime is right here. C double prime is going to be right here, and B double prime, if I count down 5, should be at, what, negative 5, negative 5. B double prime, and I'll draw my line, some sort of variation of green. okay? So again, we go from the composition, the order goes from here to here. Okay, so again, we're going to do composition. I've already drawn the first triangle. So our first composition is going to be this is going first, our reflection over the y-axis, okay, which we already drew. So what I'm going to do is I'm just going to copy this in. So I'm going to take all of this and just paste it. Okay. And I can just copy and paste that triangle again because it's the same. Okay, there we go, all nice and copied over. So now what are we going to do is we're now going to take these points and now we're going to translate them 3, -2. So a translation of x plus 3, y minus 2. That's just another way to write our translation rule, right? So what does this mean? It's I'm taking each x value and adding 3 to it. So -1 plus 3 is a positive 2. 2 minus 2 is 0. -5 plus 3 is -2. 5 minus 2 is 3. -5 plus 3 is -2. 2 minus 2 is 0. So there's our new coordinates. So A double prime is at 2, 0. B double prime is at -2, positive 3. And C double prime is at -2, 0. So here is my composition of my new triangle. So now the question is, does order matter? So if I did the reflection of the y-axis first and then the translation, or if I flip-flop those, would it matter? So we're going to find that out right now. So now I'm going to first do the translation, then I'm going to do the reflection and see if our final picture ends up like it was here. So I'm going to do our translation first. So A prime is now at 4, 0. B prime is now at 8, 3. And C prime is now at 8, 0. And again, how did I do this? I took our original points and I added 3 to all the x values and subtracted 2 from all the y values. All right, so I'm going to graph our new picture. 4, 0, that's A double prime. B double prime is at 8, 3. There's B double prime, and C double prime is at 8, 0. No, this is not double prime. This is regular prime. Excuse me, because now this is our first picture, not our second picture. So, fix that. That was a terrible line. Okay. So there it is. So now we're going to reflect this over the y-axis. And again, the rule for reflecting over the y-axis is to take your points and make your x value change sign or make it negative. So I'm now going to be at -4, 0. And again, I'm going from these set of points. It's the next one. -8, 3. -8, 0 is my reflection. So here's A double prime. Here's C double prime. And here is B double prime. My line. So the question is, if I change the order, is the composition the same? And very clearly, you can see these are two very different pictures that all started the same, but if I change the order, obviously the pictures will look different. So order matters. Make sure you read this from left to right, or from right to left, or else you're going to be doing it incorrectly. So the question is the composition transformation commutative, meaning does order matter? And the answer is no, order matters, because the commutative property order doesn't matter. So this is not commutative. No order matters. Okay? And then the example 3 on the practice worksheet you do not have to do. All right, that's all from me.